Hai, Assalamualaikum. Group 65, SKAA 2012 Civil Engineering Lab 1, Open-Ended Experiment, Rock Mechanic, Dr. Muhammad Irfan bin Shahrin. Our group member, Nik Aziz bin Matnur, Hamim bin Syayuti, Nurul Rauda binti Muhammad Nur, Nuriza binti Kamarudin, Nur Haslina binti Halim.
Schmidt Rebound Hardness Test. Introduction. Schmidt's rebound hardness test is carried to determine the rebound hardness of the test material, particular rock, by using the Schmidt's impact hammer. With the portable, simple and affordable attribute, the Schmidt hammer is ideal index apparatus which underline to increase the popularity and expanding reach the application. The HH rebound hardness value are is sharp, the most frequently used index and rock mechanic particle of estimating the initial compressing stress and the modulus elasticity E of intact rock both in laboratory condition and in situ. The SH is also widely used for estimating the UCS of discontinuity wall and assessing the workability, excavability, and bowability of rock by mechanical mean, cutting, polishing, milling, crushing, and fragmentation process in quarry drilling and tunneling. The device is portable and may be used both in the laboratory and field. The objective: to determine the hardness and initial compressing strength of rock. Theory: straightforward principle apply when operating the Schmidt hammer shown in Figure 1. A constant amount of stored spring energy imparted through the hammer mesh to the plugger, causing the mesh to rebound a distance proportional to the total energy absorbed by the impact surface. The rebound hammer index is shown by the indicator and is defined as the rebound index. The degree of rebound varies dependently upon rock elastic property. The height of rebound of the mesh is measured on the scale and is taken as the measurement of the hardness. Apparatus: the Schmidt hammer type L with the impact energy of 0.74 Newton meter, sample cradle steel of minimum weight of 20 kg. Note that when the sample cradle is the used hammer is vertical downward. This is working principle of the Schmidt hammer. Procedure: Number 1. Prior to each testing sequence, calibrate the Schmidt hammer. Number 2. Specimen obtained for the laboratory test should be representative of the rock to be studied. Use the larger piece of the rock if possible. The test surface of all specimens should be smooth and flat over the area covered by plugger. Number 3. Securely clamp the individual piece of rock to rigid base to adequately secure the specimen against vibration and the movement during the test. Place the base on the flat surface that provide the support. Number 4. Use hammer in one of the three positions: vertical outward, horizontal, or vertical downward, with the axis of the hammer 5% from the desired position. Record and report the hammer orientation for the test and any correction applied to non-vertical or non-horizontal orientation in the result. Number 5. Conduct at least 20 individual tests on the rock sample. Separate the test location by the digital of plugger. Seterusnya adalah ujian Schmidt hardening hammer yang selalu kita guna untuk test structure yang tidak perlu pergi ke lab. Dan ini adalah alat yang kita panggil Schmidt hammer, ataupun orang panggil selalu dekat sana orang panggil rebound hammer lah. Sebelum alat ni digunakan, selalunya kita tengok dulu alat ni dia buat calibration ke tidak. Macam mana nak tahu? Alat ni mesti ada stiker calibration daripada lab selalunya. Kemudian kita lihat di badan hammer itu sendiri, ada nilai yang boleh dibaca dan ada graf yang kita boleh merujuk berapa nilai yang dikeluarkan itu, supaya kita dapat tahu nilai yang tempat yang kita test tersebut lah. Terusnya kita mulakan test dengan cara kita melepaskan hammer di dalam alat ini seperti ini, dan kemudian kita tekan sahaja ke dalam. Kita tekan sahaja ke dalam, secara automatik hammer tersebut akan memberi bacaan di meter dia. Kemudian kita rujuk bacaan tersebut di graf di sebelah dia. Baik, kemudian kita dapatlah berapa. Kemudian kita lakukan ujian dengan posisi yang berlainan. Seterusnya kita lakukan ujian dengan posisi melintang, sama seperti tadi. Kita lepaskan hammer, kita tekan ke dalam supaya dapat bacaan. Bila dapat bacaan, kita rujuk kepada graf di sebelah, dan kita dapat tahu nilai daripada RE number tersebut, berapakah bacaan struktur tersebut. Bacaan tadi kita rekodkan di dalam jadual untuk dianalisis data dan dibuat kesimpulan.
Hi, I am Nozlina. I want to tell you about calculation. The calibration curve in chart A assume the rock density of the order 2000 kg per meter cube. The curve applies with the hammer in the horizontal direction vertical rock surface. If the hammer is used in other way, orientation, the correction factors in the table below must be applied to the rebounding volume obtained. The rebounding index is to show by the indicator and is defined as the rebounding value. The degree of the rebounding varies. It depends upon rock elastic property. The height of the rebounding of the mass is measured on a scale and is take the measure of hardness. Open index experiment, rock mechanics. G4-3 point load test. Introduction. Point load test is carried out on the cone rock segment or irregular rock fragment to obtain the point load strength index IS50 and unconfined compression strength. This test does not require costly specimen prepare and is quite simple test. The failure load P and the distance between platelet D are measured to obtain the uncorrected point load stress P/D2. A correction is applied to account from the specimen size and shape, and the unfounded compression strength is obtained from correction equation. Depends on the specimen geometry. Three types of tests can be performed: diametrically, axially, and regular sum. Testing produced as suggested by ISRM 2007. In the figure 1, specimen shape requirement from A, the diameter test, B, the axial test, C, the block test, D, the irregular sum test, ISRM.
Objective: to determine the compressive strength of rock specimens from irregular lump tests. Theory. When first introduced, the point load strength test was used mainly to predict unusual compressive strength, which was then the established test for general-purpose rock strength classification. Point load strength now often replaces the unusual compressive strength in this role, since when properly conducted, it is as reliable and much quicker to measure. LS50 should be used directly for rock classification, since correlations with unusual compressive strength are only approximation. On average, unusual compressive strength is 20 to 25 times point load test. However, tests on many different rock types, the ratio can vary between 15 and 50, especially for anisotrophic rocks, so that errors of up to 100 and are possible in using an arbitrary ration value to predict compressive strength from point load strength. The point load strength test is a form of indirect tensile test, but it is largely irrelevant to its primary role in rock classification and strength characterization. LS50 is approximately 0.80 times the unusual tensile or Brazilian tensile strength. Procedure. First, rock blocks or lumps of size 50 to 35 mm and of the shape shown in figure 1D are suitable for the irregular lump test. The ratio D over W should be between 0.3 and 1.0, preferably close to 1.0. Second, there should preferably be at least 10 tests per sample, more if the sample is heterogeneous or anisotrophic. 3. The specimen is inserted in the test machine and the platens closed to make contact with the smallest dimension of the lump or block, away from the edges and corner, figure 1D. Fourth, the distance D between the platen contact points is recorded 2%. The smallest specimen with W perpendicular to the loading direction is recorded 5%. If the sides are not parallel, then W is calculated as W1 plus W2 divided by 2, as shown in figure 1D. Fifth, the load is steadily increased such that failure occurs within 10 to 60 seconds and the failure load P is recorded. The test should be rejected as invalid if the fracture surface passes through only one loading point. Figure 2.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nariza Beti Kamarudin and I'm from group 65. Today I want to show you the point load test. Okay, the objective of point load test is to determine the strength of rock material through index test. Okay, this is the material and this is the machine. Okay, firstly, measure the diameter of sample and the length of sample. Okay, place the sample into the machine. Okay, touch the machine into the sample. Okay, and press the machine until touch the sample. Okay, first reading and continue the test twicely. Thank you.
Calculations. The uncorrected point load strength I50 is calculated is given as uncorrected point load strength I equal P over D power of 2, equivalent course diameter D power of 2 equal to 4A over pi for lump test. Minimum cross-sectional area A equal to W times D. Point load strength I50 equal to F times I, and size correction factor F equal to D over 50 power of 0.45 or from FIGG.
Thank you.